So one night I was reading one of my favorite science fiction books called Hitchhiker's Guide to the Galaxy. And there, as you can imagine, it's a story about aliens and space travel. And they used, by their words, the fastest spaceship ever built that can go anywhere in a part of a second. And it was driven by the so-called infinite improbability drive. It is called this way because the chances to be invented were 0 to infinity. And this is almost identical to how I felt about distributed parallel testing and the lack of tooling. This is how the title of the presentation came out. Of course, today I will not talk about interstellar travel rather than distributed parallel testing. And the main question that I will try to answer will be how we can deliver high-quality software faster. My name is Anton Angelov. I am CTO and co-founder of Automate the Planet, and I have more than 8 years of experience in the field of automated testing. And for 6 years, I worked in the two biggest companies situated in Bulgaria. And part of my job was to design and write highly scalable test automation solutions. And at the same time, I consulted a couple of companies regarding their test automation efforts and led several trainings. And I'm honored to be nominated for the Best QA in Bulgaria for 2017. So, here is our game plan. And even if you don't have the goal to speed up your test execution, I believe that you will find lots of insights related to distributed testing. And to the end of the talk, you'll know how you can speed up your test execution through running your tests in parallel. And also, if you need it, you'll know ways how you can optimize your continuous delivery, and you'll learn some common problems and challenges in running your tests in parallel, and we'll talk about some solutions. First, let me try to quote the State of Testing report for 2017 by Smart Bear. 68% of the people want to deploy weekly, daily, or multiple times a day. And to the end of the presentation, I will give you lots of examples from my company how we can manage to release our product multiple times a day. So here, by heavy tests, I mean tests that take more than 1 second to execute. And usually, these are database integration tests, UI tests, API tests. And their execution time starts from 1 second to a couple of minutes. And on average, we can accept that the approximate speed of such test is equal to 30 seconds. In the different channels, Automate the Planet has over 25,000 followers. And we asked them to participate in a short survey. So I will use some data to illustrate some points. And it summarizes the practices for more than 50 companies. For example, here, this is the first question that we asked them. How many tests do you have and what type? So I summarized the results in 5 groups based on the count of these heavy tests. And as you can see here, half of the participants mentioned that they have between 500 and 1,000 heavy tests. So, on average, we can conclude that most companies have around 750 heavy tests. And we mentioned already that the average test execution time is equal to 30 seconds. This means that if you want to execute all of these tests on a single machine sequentially, you need more than 6 hours to execute all of them. So, if you want to execute all of these tests in continuous integration or using them for continuous deployment, this will be impossible. Why is that? Because sometimes if you want to deploy multiple times a day, your test suite should be able to execute 2 to 3 times a day or under 3 hours. And this is so because sometimes there are bugs in the tests or problems occurs during the test run. So you need to repeat the whole process again and again. Our second question to our followers was, when do you execute your tests? And their answers were similar to the statistics from the year report. Almost 40 of them mentioned that they already execute their tests in continuous integration. But if we take a closer look to the numbers here, we can conclude that 60% of the people struggle with the speed of their tests. And even there were some edge cases. Some people mentioned that they execute their tests only nightly, during the weekends, weekly, or even monthly. I can define at least 3 types of parallel testing. Usually, the most unit testing frameworks has native support for running your tests in parallel. So, if you have 100 tests and want to execute them on a single machine with 5 CPU cores, this means that 20 tests will be executed simultaneously on each core. However, not all test frameworks support this option, and there are a couple of problems related to the type of the test that you want to execute. Your second option is to execute all of your tests on different machines, and then later merge the results. And usually people use some complex tooling, for example, Microsoft Test Agents. And your third option is, of course, you can mix both approaches. So you can use the complex tooling to distribute your tests on multiple machines, and then run all of your tests in parallel on each machine. So in our observation, the optimal number of test run processes is equal to 1.5 up to 2 multiplied by the CPU cores of your machine, which means you're limited to the hardware you use. In my past experience, in most of the teams where I worked, our test machines had up to 2 CPU cores, which means that the optimal number there of test run processes is equal to 4. One big machine or many smaller? To answer to this question, I need to tell you the difference between horizontal and vertical scaling. Horizontal scaling means adding more machines to your pool of existing resources, whereas vertical scaling means adding more power to an existing machine like CPU or RAM. And usually, many smaller machines are cheaper than one big one. What are the advantages of running your tests distributed? The most obvious is speed. Instead of executing your tests for 16 hours, you can run them for 4. Since you can run your tests daily, multiple times, you can release your application multiple times a day. But even if you don't have this goal, you can improve significantly the quality of your product by shortening the feedback cycle, by integrating all of your tests in your continuous integration process. This way, you have higher coverage in shorter throughput time, and since your tests will be executed more often, their return of investment will increase, and you will be able to locate more flaky tests or not well-written, unstable tests. To tell you why our company developed the tool, I need to tell you what we needed to test. Our company specializes in building test frameworks and tools for testing web, mobile, desktop, and API. And it's not some kind of a visual tool for codeless testing or whatever. It is a set of .NET libraries and tools for speed up test writing and maintaining your tests. So, for example, for the web library, we use WebDriver in its core, but add many capabilities on top of it. And we support 8 different browsers. So, for example, for the Selenium grid mode, we have a lot of tests for the integration with cloud providers also. And we have tons of other logic that needs to be tested. So we ended up with 5,500 UI tests. And I don't count all of the unit tests that we have, because they execute quite fast. And actually, our UI tests are quite fast too, because we use Bellatrix to test itself. However, if you execute all of these tests on a single machine, sequentially, you will need 14 hours to execute all of these tests. And here you can see an image of our Visual Studio Team Services build. This is how Meissa was born. What is Meissa? Meissa is open source distributed test runner. It is written using the latest Microsoft technologies, such as .NET Core, ASP.NET Core, and many more, meaning it's completely cross-platform. And it is designed to be programming language agnostic, which means that you can run tests written in different languages, like Java and C#. What are the most prominent features? It can distribute your tests on multiple machines. Then it can smartly balance your tests by getting the previous execution times. It can also has the capability to retry all of the failing tests so that you can see whether there are bugs in your tests or problems in your application or some random environmental issue occurred during the run. It is shipped as a single command line interface, so no more complex setups and configurations. It has the capability to keep the clean state of the agents and provides a way to easily cancel the runs and so forth. And as mentioned, it's cross-platform, meaning that it can run tests on Windows, Linux, and macOS. So, as I mentioned, we had 4,500 UI tests. They executed for 16 hours sequentially. And with Meissa, they run for 4. And even we didn't use the in parallel option because I forgot to mention, but Meissa can run your tests in parallel on each machine. However, for the UI tests, we don't use it. So here you can see the same build. It ran in approximately 4 hours. So in order to coordinate all of the work, Meissa has its own server. So you can start the server with the keyword in its server. And by the way, to run Meissa, you do not need to install .NET Core or any other dependencies because it's completely portable, meaning everything you need is in a single zip file. Agents, runners, servers, databases, .NET Core, everything. So next, you need to start Meissa in test agent mode. And usually you have 1 agent per machine, meaning that more machines you have, faster your tests will be executed. You start the agent with the keyword test agent. And next, you need to specify the correct test server URL. It is formed by the IP address of the machine where you have started Meissa in server mode. Next, you need to mark each agent with a specific tag. Later, you can use these tags when you run your test to filter on which machines your test will be distributed. And this way, for example, when you run your UI tests, most probably these machines will be stronger than the ones that you use for executing your API tests. Usually, you start the runner from continuous integration job, like a Jenkins job. And the workflow is as follows. You download the source code of your tests, then you build your projects, then you start executing the tests with Meissa, and then you publish the results to Jenkins, for example. So you use the keyword runner to start running your tests. Then you need to specify the results file path. This is the path to the file where Meissa will save the results after they are merged. Outputs files location is the folder where your test files are located. Usually they are moved there after you build your projects. The test technology is actually needed to point which native test runner should Meissa use. Right now we support MS Test Core, MS Test Framework, NUnit, and later more languages like Java will be added. And the last one, the test library path, is the path to the file where your tests are located, like a DLL or a file. And now I will go through some common commands that unlock the full capabilities of the tool. This one, we can use it to pass this value here to the native test runner. For example, with this command, we tell the .NET Core native test runner to produce a detailed log. You can pass any value you wish, as long as the native test runner supports it. With the next one, we instruct Meissa to retry the failing test 3 times if 5% of all other tests have failed. And by the way, the retry test will be saved in a dedicated results file mentioned here. Also, the tool has a complex filter parser, so you can filter your test during the run. And sometimes it is useful to pass data from the runner to the test. For example, if you want to pass the current build number from your continuous integration tool and produce a unique folder, for example, then you can use this command, and then on each agent, a separate new environmental variable with the name build number will be created, and the value 42 will be assigned. Then it's really easy to get this value from your tests. Next, if you use this argument, then your tests will be distributed based on the previous execution times. However, you need to make sure that you need to execute all of your tests at least 1 time before using this option. And lastly, if you use this one, your tests will be run in parallel on each machine. And you can even specify here the processes that need to be spawned on each machine. And this is most useful for unit, integration, database, or headless UI tests. If you need help, you just use the keyword help here, and all of the available keywords will be displayed with description. And if you want to see all of the available arguments about some keyword, you just type first the keyword and then the argument help. I had the job to make a research how to solve the problem in our company. So I read lots of articles for a couple of days, besides all of the solutions I know from my past experience. And the truth is that for 8 years, the ways how people run their tests in parallel has not really changed. So in addition to my research, we asked our followers, how do you run your tests in parallel? And their answers were almost identical to what I read. As you can see, 6% of the people mentioned that they use Microsoft test agents. Others mentioned that they use custom tooling, or they use their continuous integration tool to execute their tests in parallel. However, the most of them use their native test runners capabilities to run the tests in parallel based on the CPU cores of their machines and leveraging the Selenium grid. Of course, if you are talking about UI tests. But this has a couple of problems. First, most of the test runners, in order to run your tests in parallel, they can do it only if your tests are placed in separate projects or containers. Meissa can do it even in a single container without modifying the source code. You can find more correct examples in our documentation about that. If you use the native test runner capability to run your tests in parallel, then great. You can use it side by side with Meissa, and your tests will be executed with the same speed. However, you will have all of the benefits of the tool, and most importantly, you will be able to distribute your tests on multiple machines. Now, some popular solutions for testing environments now utilize Docker containers. One of my favorites is Selenium. Most probably, most of you know what Selenium is, but let me just explain it. It is basically a Selenium grid on steroids. It provides clean browser installations in separate containers. It is excellent for executing WebDriver tests if you want to execute them in Chrome, Firefox, or Opera. How it differs from Meissa? Well, it's not a test runner. So if you want to run your tests in parallel, you still need a way to execute your tests simultaneously. And I considered it during my research. However, as I mentioned, we developed not only tools for web, but for mobile, desktop, and API. So the biggest problem for us was that we were not able to execute APM or desktop tests using containers. So, of course, it is open source, so you can use the existing images and then build new ones on top of them. This is fine, but it was too much work for us to use it. The same is valid for the standard Selenium grid and for its tuned versions like grid router, selenograph, JSON wire grid, and so forth. They are not test runners. You still need the way to execute your tests in parallel. For example, if you run your tests in one process, even if you have 100 hub nodes, your tests will be executed one by one. So you can use them together with Meissa to execute all of your tests distributed on multiple machines. As I mentioned, because of the lack of tooling, some people use their continuous integration jobs to execute their tests in parallel. Usually, the usual practice is to mark all of your tests with attributes or annotations in Java, like machine 1, machine 2, machine 3, and then use your continuous integration tool to execute your tests on the different machines. However, this is unacceptable for me because the balancing of the tests is manual. For example, if you add new tests or remove existing ones, you need to calculate that time in your head, which is unfortunate. And usually these tools produce multiple test results files, and you need a way to merge these results in a single file. Previously, in my previous company, we used Jenkins jobs for that, and then we used some kind of a strange plugin to merge the results. Meissa can distribute the tests without modifying the source code and then produce a single result file. That's it. Usually, I love the Microsoft tooling, and to be honest, we used Microsoft test agents in my past company for a couple of years to distribute our tests. However, they have a couple of problems. For example, they're hard to set up and troubleshoot. The balancing of the test is black box. The documentation is missing almost entirely. And the biggest problem for us was that when you cancel the build, some of the agents left in an inconsistent state, meaning that they were open browsers and so forth. Well, our tool, Meissa, is shipped as a command line interface, a single command line interface, and it's cross-platform. Instead, usually, by the way, Microsoft tools execute only on Windows, which is unfortunate. So, Meissa has many moving parts, runners, agents, servers, and so forth. They're, as I mentioned, they're all distributed as a command line interface, single command line interface. And first, you need to start the server. Then it synchronizes the work between the runner and the agents. And the first time when you start the server, a portable SQL database is created. It contains, for example, the exceptions, the test execution times, logs, and so forth. Then, a web service is self-hosted using the portable web server of ASP.NET Core Kestrel. Then the runners and the agents communicate between each other using the server via HTTP. So you need to make sure that the server is up all the time because the runners and the agents don't have separate databases. Now, the first time when you start an agent, it registers itself as active. Then it continuously asks the server whether there are new scheduled test agents runs to be executed on this particular machine. When the run starts, then the so-called extensibility points plugins are loaded. You can use them to execute your own logic in the pipeline of the test execution, for example, before or after a test run or an abortion. So at this point, the code from all plugins is executed. Next, the so-called test technology plugin is loaded. It is important because the tool uses it to locate the tests, to execute them, or to merge the results. Next, based on the parallel options, the agent creates multiple test batches. And then it starts the processes and waits them to finish. Next, the test runner. When you start it, again, these so-called extensibility points plugin are started. Then the logic from them is executed. Then the test technology plugin is loaded, and we use it to locate the tests, filter them. Then, based on the available test agents, the runner distributes the test across all the available machines. Then it zips the output files and sends them to the server where each agent can download them. The next part is where the runner waits for all agents to finish. At the same time, in a separate process, the runner continuously checks whether there are new messages published by the test agents to be printed on the console. In one more process, the test runner verifies the health of all agents. And in one more, it verifies its own health. And if some of the agents don't verify its health, then the whole test run is aborted. At the end of the process, the runner merges the results from all agents. And if the Meissa's try failing tests option is turned on, then the whole process here is repeated again. And if some of the tests succeeded, then the test result file is updated. At the end, again, the logic from the extensibility point plugins is executed, and the test run is completed. So, there are lots of benefits to execute your tests in parallel. However, there are lots of challenges to overcome before you are ready to speed up your test this way. So I will mention a few, and I will try to give you some sample solutions. For example, for me, the most significant one is to making your tests not depending on each other. And now I will give you an example from a company where I worked in the past. In this particular team, they had to test an e-commerce platform, and their job was to verify what our clients will see in their account after the client made a purchase. And they used a single test client with hard-coded data. So, for example, when they run their tests sequentially on a single machine, everything is fine. But when they run them in parallel, the data messed up. And this is so because sometimes test A can modify the data of test B and vice versa. How we solve the problem? Well, we refactor the tests so that they use a separate new client each time. However, the processes for creating new clients took too long, for example, 30 seconds or more. So it was unacceptable to create the clients inside each test. So we created a separate small tool for creating new clients, and we executed it sequentially on a continuous integration job so that it ensured that we always have 5,000 new test accounts. And later in the tests, we had logic to pull, to get clients from this pool. And we used internal APIs to create new unique orders for these test clients. This is how we solve the problem. So my tip here is to execute any expensive setup or cleanup before or after the whole test execution, and each test to use its own unique set of data. Another problem, as mentioned, is that, for example, if you use Microsoft test agents or something similar, is that the state of the agents is not clean every time, and they are open browsers and so forth. So I will here share a piece of code that, as I mentioned, Meissa supports writing of extensibility points plugins, and this code is executed each time after test run. And it ensured that the processes of WebDriver are killed and all of the browsers. This is how we solve the problem. Of course, this is a short version of the code. Another UI-related problem is when you want to execute multiple browsers on a single machine and you want to video record what is happening, for example, for the failing tests. And as you can imagine, you cannot make a video recording of, you make a video recording only on the top browser, usually. So for me, in our company, the running your tests, multiple browsers on a single machine brings more problems than benefits. So we decided that we use many machines, one browser at a time. This is how we solved it. Another possible solution is to use Selenium. It's great about making videos in the containers. The same is valid for the making of screenshots. Some of you may have used WebDriver, and it sometimes, for some of the drivers, depending on the language, it makes like a screenshot of the desktop, which means that if you have multiple browsers on the single machine, you make a screenshot only on the top window. So how we solve the problem? Well, in our company, we use JavaScript to make the screenshots, and even their full page, which means that even the invisible part of the tab will be visible. And this way, even if you have multiple browsers, you'll be able to make screenshots of each tab. Another UI-related problem is when you try to create a new WebDriver session, sometimes for some drivers, WebDriver tells you that the port is already in use. And this may happen if you use proxies, for example, too. This is our solution, at least in C#. You can write the same code in Java. We get the first free port, and then you pass it to the WebDriver constructor, and this way everything works. And you can create multiple separate processes on a single machine. In our company, we use Edge web browser to execute our tests in continuous integration because it's super fast. It's like 5 times faster than Chrome. And however, it has a couple of problems. The biggest one is that it is designed in a way where it is impossible to start multiple WebDriver sessions. This is like a design decision by Microsoft. So again, our solution here is to use many machines, one browser at a time. This is unfortunate. So when you go to the bakery to buy a bread, you do not use a shuttle. The same can be applied here. I believe that Meissa is not the appropriate choice in many cases. For example, if you have lots of unit tests and they are fast, you don't need to bother to execute them in parallel or using multiple machines or complex tooling. You can just use your native test runner. The same is valid if you're happy with your current solution, Microsoft Test Agent, CI2, Selenium, whatever. If you're happy with its speed, usability, and everything, you just keep using it. Don't bother to change it. I'm against changing the tools because some other told me or because some other tool is more viral. How to get started? You can visit our website and download the runner. It's a single zip file depending on your operating system. Then you can unzip it, start executing, and you can check our rich documentation about it. Then you'll find on the website a link to our GitHub page, so you can report bugs, suggest new features, and we are looking for people to help us to write the non.NET runners, like, for example, Java or JavaScript. So if you want to get involved, just go to GitHub and send us a message. So we talk about parallel testing, the various types, what are the benefits, how people run their heavy tests. I told you about our project, how we use it. We compare it with other available tools, and later we discuss the different challenges. And I wanted to end up with some kind of a statistics, but I thought that it might be fun to I don't know, go even further. So I created a tool for generating a lot of tests. So I use it, and we generated like 100,000 tests. Each test executes for exactly 1 second. This means that if you want to run all of these tests sequentially on a single machine, you need more than 28 hours. So I wanted to test the maximal capabilities of our tool. So I created 10 machines in the Microsoft Virtual Machines Cloud called Azure. And each machine had 8 CPUs and 14 gigabytes of RAM. The plan was to start Meissa on each of them in agent mode, and then to start 14 separate test run processes. If you recall the formula about the optimal number of test run processes, this is the optimal number for 8 CPUs. And here are the results. This is the time for running them in sequentially. With Meissa, they run for under 20 minutes. You can see it here. This is the same build. This is officially the most expensive presentation I made because these virtual machines cost a fortune. However, jokes aside, I'm really happy with the results because they show that the tool can cope with the most extreme situations. And I will end up with a quote from the CEO of the most famous programming site, Stack Overflow. It's too long to read, and I will just summarize it for you. To be great QAs, we need to improve the happiness of our developer colleagues by giving them more frequent releases, and this way giving them negative and positive feedback and improving the quality of our products. Thank you. There was a question here, where did you buy your red t-shirt? Well, I buy it from Bulgaria, so I can bring you one if you want.
Could you say, please, is your Meissa just for Java application or for Python can run too?
As I told you, they're plugin system. So right now you can run C# tests using all of the major frameworks. But since it's open source and we have plugins, you can write a runner for Python and you will be able to use all of the benefits for distributing the tests and so forth. The same is valid for Java and other languages. Yeah, there are 2 questions.
I have checked your commits on GitHub, and you are the only committer there.
Sorry?
How about buzz factor? And if something goes wrong with you, then this project fucks up.
We can discuss that later if you want, during the pause.
Hello, I'm a bit new in the subject. Could you please explain me the difference between the thread and the process?
It's the same for me. I use it like a synonym.
Okay.
Actually, in .NET, it's called a task parallel library or something like that.
Thank you for your presentation. Such a question. You indicated that you can, via the command line interface, indicate the percentage of tests that failed, and afterwards you run the tests. But what tests are you run? The whole bucket of tests or only failed ones?
Only the failed ones.
So Meissa indicates it by itself, yeah?
Yeah.
Okay.
You have a plugin that is responsible for extracting the failed tests, and then the tool creates a separate test lists or whatever it is for your test runner. Because, for example, for NUnit, it's different how the tests are running compared to .NET Core, for example. And the same will be valid for Java.
Okay, thanks.
Do we have more questions? Okay, thank you.